rangerforce.com.
Networks revision. So the first thing you need to know is the difference between a LAN and a WAN, and they could ask this in the exam. A LAN stands for local area network, and the keyword there is local, so it's in one place, usually a small geographical area located in a single site. So that's why we usually go for businesses or schools or university. The key is that all the hardware is owned by the organisation, and it can be wired or wireless. So in your own house, that's a LAN. When your phone, your TV, your computer connect to your network that you own, that is a LAN. A wide area network is a WAN. It connects LANs from different geographical locations together. So the reason you can play someone online from another house, in your house you might have a local area network that's got your computer on it, and your friend might have a local area network at their house. You're being connected together through a WAN. Okay, and the largest WAN that exists is the internet. Unlike a LAN, organisations hire communication lines. This makes it more expensive than a LAN. In a LAN, you own everything, don't you? But in a WAN, you don't. You're having to find a way of getting that message from your house to another house. How do you access Facebook? Well, that Facebook is being stored on a server somewhere. The message you send has to get there through wires, and those wires have to be paid for. So they're connected via fibre optic, copper and telephone lines, satellite links or radio links. And like I said before, the biggest WAN is the internet. So why do we network? Well, we haven't always networked. Networking is a relatively new ability, really. In the old days, a file would be trapped on a computer, which is brilliant if you want everyone to come and look at that file on your machine. But what happens if you want to get that file off that machine? What happens if you want to send a message to somebody else? What happens if you want to send them a picture or a video, or you want to play games? You've got to find a way of making your computer talk to another computer. So sharing files is easier on a network because we're connected. We can work collaboratively. So I can open a document and somebody else can come along and we can brainstorm some ideas and work on the same document in real time. Share the same hardware. So we don't have to buy lots of printers for every computer. So that hasn't got to be in an office. Each computer hasn't got to have a printer sitting next to it. You can have one in the room and everyone just sends their print jobs to that printer when they need to use it, which saves a hell of a lot of money. The internet connection can be shared between machines and can install and perform updates on computers. And we have user accounts. So let's look at those last two. If we want to update a machine, and we've got 30 machines in the room, if they're not on a network, we have to go into each machine and update every single machine. But if they're networked, we can send one update out and they all get updated, which is faster. User accounts. So one machine doesn't belong to one person. Somebody else wants to use the computer, they come along and they just log on. So topologies. Bus, star and ring. The star network. All the PCs have a cable connecting them to a central PC or a server, as the diagram shows. If a cable breaks, only that machine that's being connected to the server is out of the game. Okay, so let's say a laptop, its connection method drops out, it doesn't affect anyone else. And it's easy to add new things to it. So in your house, your friend comes around, they want to use your Wi-Fi, you give them the code, they've connected to it. Straight away you can add more devices on. You just keep adding people in. However, they're costly to install, you need a powerful server in the middle, and they're dependent on a central computer. Bus. All PCs are connected through a single backbone. Only one computer can communicate at one time. So this machine here wants to talk to this one, sends a message down the line, passes it along until it gets to the right one. If this one's sending a message, this machine can't send a message, this one can't, so everyone else is having to wait while this is coming through, which is a bit of a nightmare. If this main cable breaks, the whole network goes down, and it's low performance if the network's busy. A ring network. all connected adjacent in a ring. Computers take it in turn to pass a token round. If you've got a token, that means you can talk. So you pass it around to the computer it's meant to go to. This computer wants to talk to this one, has a token, pass it around. He hasn't got the message for him, so he passes it to the next one until it gets to the right one. If a single PC or the cable breaks, the network goes down. However, they're not dependent on a central machine or a server, and it's consistent performance even when busy. Network protocols. A protocol is just a posh word for a rule, and that determines how devices communicate, how communication should start and finish, and how data is organized. What should happen if it goes missing? So we know everything is broken down into zeros and ones into binary. Well, what do those zeros and ones mean? That's why we need some sort of rules. How do we know when the other person has finished sending their message? And what happens if something goes missing? If a message comes across the internet, it doesn't always follow the same path. We're going to look at that in a minute. What happens if something goes missing? What happens? MAC addresses. They're a unique identifier on a network. They're assigned by a manufacturer and cannot be changed. So they're written onto the chip, onto the actual board. We convert them to hex. So in this example, 1001100 will be converted to 98, so that we can read them as humans. But the idea is, it's like a phone number that's printed onto the actual circuit board that never changes, so we know who they are. An IP address is different. These are used when sending data on TCP/IP networks. Unlike MAC, they are not linked to hardware. So a MAC address will be the same for the life of that piece of hardware, but an IP address can change. If your phone connects to your home network, you'll have an IP address. If you connect it to another network, you might not have the same IP address, you'll have a different one. And we've got two types. We've got static and dynamic. So static ones are assigned manually. You decide what the IP address is going to be. They're a permanent address, usually used on a printer. So if you think about it, you don't want the printer address to change all the time. You want to know where that printer is all the time, so it doesn't need to change. Automatic ones are dynamic. They're assigned to a machine. That's more cost effective and can be reused. So 192.168.0.1 is usually a home address on a local area network. If you look at your router at home, that's probably your router address. It probably says on the back of the router itself. So then your PC might be given the IP address 192.168.0.5. And it doesn't really matter, you can just keep reusing them, no one's being wasteful with them. Hardware. To get connected, we need a network interface card. And then if you look on the back of your computer, you've probably got that where the Cat5 cable goes. That allows us to get data off the motherboard onto a network. It allows us to communicate. We usually communicate with Cat5 or Cat6 cables or Ethernet cables, but fibre optic is faster as it transmits data as light, high performance and more expensive. Switch and a router. Switch connects devices on a LAN. They transmit data to a device on a network via its MAC address. That's its only job. So one computer sends a message to another one, they go to a switch, the switch knows what the MAC address is of the computer you want to go to, and it sends it across. Routers transmit data between networks. They're like our gatekeepers that allow you to connect to the internet. So you can have a network interface card on your machine, but unless you've got a router in your house, how are you going to get onto the internet? And we talked about that before. A WAN is a connection of networks. What a router allows you to do is join the biggest WAN, known as the internet. They direct packets to the correct destination. So a packet might be part of an email. You want to send an email to somebody else's machine, or they use an email server like Hotmail. How is it going to get there? That's what your router's job is to do, is to take the packet from your machine and find its way across the internet where it needs to go. Used in homes and offices to connect a LAN to the internet. So connect your house onto the internet. Our school onto the internet. Wireless. Use radio waves. To set up a wireless network, you need a wireless access point, or a WAP. A WAP is basically a switch, like we talked about before, that allow us, instead of connecting through cables, they connect through Wi-Fi. It's not to be confused with a hotspot. A hotspot is just a location where you can connect to a WAP. Client-server and peer-to-peer networks. So basically two major types of network. We can have client-server and peer-to-peer. In a client-server, it kind of does what it says on the tin. You've got clients and a server. There needs to be a network manager. The backups can be done centrally, centralized security and shared resources. So that's what we've got in school. We've got one server. When you use a machine, all your files are being backed up onto the server. And this server is being looked after by somebody. So that's going to cost money. However, if we want to update a version of, let's say, Word, we want to update to new Office, we just send it from the server and all these machines get updated, which is useful. In a peer-to-peer, all the machines have got an equal status. They're easy to maintain and set up. There is no centralized management system, so nobody would have to pay someone to look after this. Backups have to be done by each machine separately. So if this one goes down, there's no way of this machine getting those files back. Whereas on this one, because these files were backed up onto the server, we can just get them back off the server. But this one has no server. They're not dependent on a server. TCP/IP. TCP/IP is a protocol which dictates how data is to be sent on the networks. Basically, it's two protocols put together. Transmission Control Protocol means it's basically how the data gets split into packets and reassembles the packets, checks if the data has arrived and if it's correct. The IP, the Internet Protocol, is responsible for the actual packet switching process. Okay, packet switching. What is a packet? All data that goes on a network is sent as a packet. So you're trying to send a picture, the picture gets broken down into these little packets. Every packet has a header, which is kind of like the envelope that the letter goes inside. And on the packets, packet header, we have a source and a destination address. So where's it coming from and where's it going to? Inside the envelope is our letter, which is our payload, which is the important thing that we're trying to get to somewhere or get from somewhere. Okay, so this animation kind of shows how packets get sent across the internet. The sending device splits the data into packets and they're sent across the network. Each packet is given a number to show the order of its data. Each router reads the packet header and decides which way to send the packet according to IP rules. The way the data is sent changes depending on network traffic, so packets can take different routes. If a router receives too many packets at once, it may prioritize some over others. As the packets take different routes, they can arrive in the wrong order. The receiving device uses the packet numbers to reassemble them in the right order. Sometimes packets go missing in transit. So the receiving device checks periodically that all the packets have been received. If it hasn't been received for a while, it sends a timeout message back to the sending device. If all the data is received, a checksum is performed and it knows the message is intact. TCP/IP. Coming back to it again then. So now we've seen how that works. The Transmission Control Protocol splits the data into packets, and they're reassembled, checks if they've been arrived. The IP protocol is responsible for that packet switching that goes on. We can see that that's one of our protocols. The secure one means that we're accessing this web page securely. The domain name is the address of where this file is sitting, and this is the path to the file we want. So Radio 1 is a folder on this web address, and inside there, index.html will be a file inside this folder. So anything right of the address .co.uk or .com is the navigation of where you would find that file. Domain names such as bbc.co.uk are easier to remember than an IP address. So the server where this sits on will have a number, but remembering those numbers is really, really hard. As humans, we can remember words a lot easier. So we use a DNS server, or a domain name server, which converts and looks up an IP address based on what we type in. So if we type in bbc.co.uk, domain name server might know that that sits on, I don't know, 195. Whatever, converts it and takes you to the right page.